Hi, and welcome to today's webinar, Why App Platform is a Better Alternative to AWS for Startups. My name's Diane Hannay. I'm a Senior Manager in Product Marketing at DigitalOcean. I'll be giving you a brief introduction and then handing over to my colleague, Jack Pearce, who's a Solutions Architect out of our London office. Jack will be taking you through a demo of deploying an app, showing you the auto-scaling feature, and also a little bit about how to use the dedicated IP feature. Then Jack will be handing on to Adrian Stanek, CTO of webbar in Germany. Adrian is a long-time customer and a partner of DigitalOcean. He's also a huge fan of App Platform. A couple of housekeeping rules before we get started. The slides and recording will be made available after the session. Please do ask any questions you have in the chat and we'll address them in the Q&A at the end. And also there's a blue box sitting at the top of your screen, request follow-up meeting. This is a great way to get in touch with DigitalOcean if you'd like to learn more. So introducing App Platform. It's a container-based platform as a service or PaaS offering from DigitalOcean. It's a particularly versatile offering because it has the ability to manage APIs, front-end apps, back-end services, full-stack apps, and databases. App Platform also supports various programming languages and frameworks, including Node.js, Next.js, React, Python, Ruby, Go, PHP, Flask, Django, Laravel, Docker files, and static sites. It integrates easily with other DigitalOcean products like Kubernetes managed databases, Spaces object storage, and essentially provides a very comprehensive cloud solution that's an alternative to the hyperscalers. So why App Platform for startups? Well, there's three key reasons. The first and probably most important for startups is it's cost effective and gives you predictability in your costs. We often hear from customers that are moving across from AWS that they find it difficult to understand their bills, and they've also experienced bill shock. With DigitalOcean, you can manage your budget effectively without unexpected costs. The second reason is ease of use. There's a fabulous UI, and it's quick and easy to deploy from a Git repository, very developer friendly, and no need for DevOps resources. And the third reason, scalability. As I've mentioned, you're going to see a little bit from Jack about how to set up the auto scaling and how it works. And that enables you to handle traffic spikes with ease. So at the end of the day, you can focus on your app and not your infrastructure. With that, I'll hand over to my colleague, Jack. Thank you.
My name's Jack Pearce. I work as a solutions architect for DigitalOcean. I'm based in the UK. So today I want to show you how easy it is to deploy an application to the app platform. We're going to deploy a managed database with that application as well, a back end and a front end, and just show you kind of how easy the app platform is to navigate and how easy it is to get an application up and running. So I want to deploy a couple of different application types in a couple of different examples today. So the first example will be a Node.js application. We're going to use Strapi, which is an open source headless CMS. And then for my second demo, an example, we're going to deploy Open Web UI, which is a front end that can be used to interact with large language models. And then for the back end, we're going to deploy a large language model using Ollama. And the large language model that we will deploy is Phi3, which is a lightweight model and it runs well on CPU. You could also run this on DigitalOcean GPU, and we could use a larger model if we wanted to. So the application that I will deploy as a demo will be Strapi, which is an open source Node.js headless CMS. So they've got some really great demo content that we can use to deploy to an app platform, to give you an example. And the example that I'm using is on their GitHub repository. It's the Next.js corporate starter, which is a really great way to get up and running with a CMS and with the app platform as well. They've also got some excellent documentation if you want to check that out, and I can link that as well. And the other thing I just want to point out is our excellent documentation, DigitalOcean documentation, which explains every component of the app platform, how it works, how to do things like configure domains, environmental variables, rewrite, redirect URLs, etc. So it's all in here, and we will reference it a few times during this demo. So the first thing I'm going to do is I'm going to come in and I'm going to create a new app platform deployment. So the app platform will look at code in a repository. It will detect what type of code, what language you're using, and then it will use a build pack to deploy that. Or you can give it a Docker image. So if you build your application in your own CI/CD pipeline and you've got a Docker repository, you can download the Docker image from that repository as well. You could also use the DigitalOcean container registry. So we've got a few different examples here. Let's say, for example, we were using the GitHub container registry. We can also specify credentials if it's a private repository. So in my example, I've forked the demo to a GitHub repository, and I've just made very minor changes. I've just told Strapi to expect a Postgres database, and these are the environmental variables that the Strapi application will expect. And we're also going to add a Postgres database to our app platform deployment, and I'll show you how easy that is now. So I'm going to select GitHub as my service provider, and I'm going to click on edit permissions, and we're going to install the GitHub application to our GitHub account. I've selected my Strapi demo repository here, so we'll click on save. That will redirect us back to the app platform, and the app platform now has permissions to pull down code from that repo. So you'll notice in this example we have two main folders here, backend and front end. So what we want to do is we want to say that our source directory in this example is going to be backend. That's where I want to be deploying my application from, which sits in here like this. Auto deploy, we're going to leave that on. So every time I push a change to my Git repository, the app platform will trigger a new deploy. So when I click next, what the app platform is doing is looking in that repository and it's detecting what code language. So we click on edit, our first component of this application. We'll see that it's detected Node.js, which is correct. It's a web service, which is correct. There are different resource types like web service, worker. Worker would be an internal application that doesn't require a HTTPS ingress. So this is all explained in our documentation. The resource size, I'm going to come in here. I'm going to set it to 1 container for now. And I'm going to set the container size to the smallest one that we have. What I could also do is I could also set one of our dedicated CPU plans, and then I could set auto scaling based on CPU usage. So I can set the number of containers to auto scale to. We're not going to do that in this instance. We're just going to set a small shared plan. So this is the run command that we will use to run our application, which is correct. It's detected that. We need to set our port. Strapi runs on port 1337. So now we're going to add another component to our application, and that is a database. So I'm going to click on database and click add. The app platform will ask me, do I want a new dev database or do I want to attach an existing database? And what does that mean? So if I had an existing DigitalOcean managed database, which is a platform as a service offering from DigitalOcean, it allows you to run databases without having to manage any infrastructure whatsoever. So you don't need to SSH into a server, you don't need to manage an operating system or the application. You just have a database connection URL that is given to you and you can utilize that how you see fit. With our managed databases, you can resize them, you can fork them, you can restore them. These are all non-impactful, so your database will remain online if you perform any of these operations. So these are really powerful tools to get started with the database. So I've got some databases here. I could attach these to my app platform deployment and reference them using environmental variables. Instead, I'm just going to create a new dev database, which will just create a small database, fully functional. We can load it up with data. good for testing, and we're just going to give it the name DB, and we'll click on create database. So the other thing that we need to do in order for this to deploy successfully is to configure some environmental variables. So if you were deploying a Docker application, for example, you would normally pass through environmental variables. If you're running an application locally on your machine, you might have a .env file that you pass through environmental variables that way. We need to set this at the app platform level. So we'll come in and we'll click on next, and that will take us to our environmental variables. We can set them at two levels. Globally, that will apply to all components of our application, or we can just apply them to an individual component. And these can be changed at any point, and I'll show you how to do that. So I'm just going to set two places. So we set our key, our value, and we can choose to encrypt it as well if we wanted to. I'm going to use the bulk editor, and these are the environmental variables I'm going to set. How do I know what to set here? Well, this is the name of the database. We called it DB, and this host name will be automatically passed through from the app platform, and it will pass through the actual host name of the database. How do I know what to set? Well, it's really easy. We've got this documentation here, and it will explain what all of the different environmental variables do. So, for example, the variable app URL will always be the application's primary domain. So we'll save that. And then I also want to set some that are specific to the application, the Strapi application itself. So these look like this, and it's just things like app keys, token salt, etc. And what we could do is, if we wanted to obscure this and encrypt it so that we can't come in and view it again at a later stage, if this is a secret, which this would be, we'll just tick on the encrypt box here. So we've set our environmental variables globally and at the application level, and then we've got a randomly generated name. We're going to leave that. We can select which region we want to, which data center we want to deploy into. It's automatically selected London, that's closest to me. We put a CDN in front of your application automatically anyway, so we'll just leave that like that. So now we get a summary of what we're going to deploy, and we'll click on create, because even if something fails, we can just come in later and we can correct that. So instantly what the app platform will start doing is building your application. You can come into this build logs tab here. So we can see the build has started here. So it's building our Node.js application. And we can watch this through. And if there were any issues with the build or any errors, we would see them here straight away. And just to show you quickly, so when we build an application in the app platform using the user interface, what we're doing is we're defining an app spec, which is a way of defining all of the different components of your application in YAML format. So let's just copy this out into a code editor and take a look what this looks like. So here's what this looks like. And this app spec, we could commit to a code repository if we wanted to. We can then make changes to it and redeploy it to the app platform using our doctl command line tool. And just take a quick look. It's really easy format. So we've got our different components. So our database, ingress rules, our name, our region, and then our services and where we are deploying from. It's really easy syntax to follow. And if you wanted to, that's how you could control your deployment instead of using the control panel. Okay, so that's great. The app platform has finished building our Strapi application, and you can just see it's deployed it to this URL here. How did Strapi know that? Well, it got it from our environmental variable app URL that we set earlier. And we can also see that we've now got a URL up here. So if we click on this, we can see our application straight away. So if you're used to running your applications locally on your machine, or you're building an application, you're running it in Docker, and you're used to be able to just look at the Docker logs, well, we can do that here. We can view our runtime logs for our application. So here's our runtime logs here. And this would be the same as running like a Docker logs. If you're used to that, or if you run applications locally on your machine, you'll see it come up in the console. This is the equivalent of looking at that. And just quickly, I want to show you how easy it is to forward logs from an application to a log provider. So we'll just come into settings and we'll go down to our log forwarding. And we've got a number of options. We can send our logs to any of these managed log providers. We can also send it to managed OpenSearch, which is an offering from DigitalOcean. So I've got a managed OpenSearch database already created. I can just select that, give it my index name for my application. I can select the components of my app that I want to forward the logs for and click on Add Log Destination. And it's as easy as that. My logs would now be forwarded to my OpenSearch instance. I could do the same thing for Datadog as an example. So I've just made a quick change in the control panel. What does that look like? What does our app spec now look like? So if we scroll down through our app spec, we can see we've now got a new key here, log destinations. And that's what we just configured in the user interface. So any changes we make in the user interface will be reflected in our app spec. Another thing I just want to show you is I want to show you what happens if you were to make a change, and that will cause the build to fail. So what would happen there? Let's come into our app and let's just break one of our environmental variables. And save that. So this will trigger a new build, and we can come in and we can take a look at the build logs. And once that's finished building, the Strapi application will try to run and it will fail because our environmental variable is set incorrectly. What we will see the app platform do is it will know that the application is unable to run in that current state, and it will roll back to a previous deployment that was working. So we can see that the build completed, but when we try to run our application, the server isn't able to start, and that's because it doesn't have the right environmental variable. So the app platform has detected that that deployment has failed, and it has automatically rolled back to a previous deployment that was working. You can see our application is still running, and the app platform has saved us from setting an incorrect environmental variable there. What we could also do is we could come back to one of our previous deployments and we could click rollback on one of those previous deployments where we know it was working as well. So this is our failed one. These are our working ones. And this is where the app platform automatically rolled back to a previous deployment that was working. And it did that really quickly as well. And it did it without taking the application offline. Another thing you might be used to doing is accessing your application at the console level. So entering into a Docker container or running it on your local machine. This is a really good way to, you might use this to debug your application. So we can do the same thing here. So we can step straight into a console of our application. In this instance, I could use it to seed my application with some data. So that's what I'm going to do right now. Great, so we've just seeded our Strapi application with some demo data, and if we come into our content manager and our admin panel, we can see these example posts here. Now I'd like to show you how to deploy some Docker containers to the app platform. We're going to deploy a backend and a front end because artificial intelligence and language models are all the rage at the moment. We're going to deploy a large language model, and we're going to deploy as the backend, and then as our front end, we're going to deploy a web interface that we can use to chat to that language model. So I'm going to choose to deploy from Docker Hub this time. And for our backend, we're going to use the Ollama Docker image. Ollama is a piece of software that you can use to get up and running with large language models. You can run this anywhere on your local machine, Mac, Windows, Linux. It also runs in Docker containers. And the language model that we're going to use today is 5.3, which is a lightweight model. It can run on CPU as well as GPU. Because we're running it in the app platform, we're going to run this on CPU, but you could also run this on DigitalOcean GPU as well. So we're just going to use the latest Docker tag, and I'm going to change the size to something a little bit more beefy. So we're going to go 8 gigs of RAM. I'm going to set it as 1 container. So that's fine. That's all we need to do there. So that is our Ollama backend, and that will expose an API, which we can reference in a second. So I'm going to add another component, and it's going to be another Docker image. And this time it will be the Open Web UI, which is a user interface web UI. You can use this to run your own ChatGPT locally on your machine. In this instance, we're gonna host it on the app platform, just as an example of deploying a Docker image. And we're gonna use environmental variables to use our Ollama backend and our large language model. So this time our Docker image is hosted on GitHub. So we're going to use the GitHub container registry. This is the repository, and I'm going to pull down the Docker image tag of main. Now for the Open Web UI front end, there are some environmental variables that we're going to specify to get this up and running. So resource type web service, that's correct. It is running as a web service. It will be internet accessible. And then the last thing that we need to get this application up and running is a database. So that database will be used to store our user logins to our front end. So click on Add Database. In this example, I'm just going to I'm going to create a new dev database. A dev database is a small PostgreSQL database that's great for testing. It's fully functional. So we'll go ahead and leave it as the default name of DB and click on Create. So now we just need to specify some environmental variables for the web front end so that it knows how to talk to the database and how to talk to our Ollama language model backend. So let's come in here and let's set these environmental variables. We can set these globally or for individual components. So let's set them for our front end. So let's use the bulk editor and let's set these environmental variables. So which variables are we setting here? We're setting the app URL, the database URL, and we are also setting our Ollama base URL. I'm setting it to Ollama. This will resolve in this Docker container. So our Ollama component will resolve at the endpoint Ollama. And the reason for that is because we've given it the name Ollama. So it works very similar to having multiple containers on the same Docker network. They can reference each other just by their container name. So it's the same concept here. So let's save that and let's deploy this to the app platform. Okay, so this is finished deploying now, and we can see under the build logs that the build was skipped. That's because there is no build required. We're just pulling down a existing Docker image from Docker Hub and GitHub container registry. And we can see in our deploy logs that Open Web UI started and our Ollama container started as well. And I just want to quickly point out that all we had to do to get our web application talking to our database was set this environmental variable. The app platform will automatically set this to our database URL. Our database is called DB. You can see that by us setting this prefix here. And that's all that's required to pull through the database URL from our attached database. The next thing we'll do is open up a console to our OLlama image, and we will pull down the Phi3 language model. This model is 2.2 gigabytes in size, so it just takes a few seconds to download. So that's now ready to be interfaced with. We can access this language model using any OpenAI API compatible tool. So let's now go into our OpenWebUI instance. And I'm just going to select the model that we downloaded earlier. And then I'm just going to use one of these template example prompts, tell me a fact about the Roman Empire. And our language model will then start replying to this question. So we've now got our own language model private instance running on the app platform. There are two features that were added to the app platform recently. That is auto scaling and static egress IP. So I want to show you a quick demo of how to use both those features. So the app platform supports horizontal scaling, where you can add additional containers and distribute that workload across those containers. It also supports vertical scaling, where you can increase the size of that individual container. Well, now we've got auto scaling. So with auto scaling, we configure a minimum number of instances, a maximum number of instances, and a CPU percentage that we want the application to scale on when it reaches that threshold. So I'm going to show you now how easy it is to set up automatic scaling on the app platform. So I'll come in here and I'm just going to choose one of our sample apps. There's a ton of sample apps in various coding languages that we can choose from just to get started. This is the Node.js sample app that I'm going to use. I'm going to edit the size of my container, and I'm going to select one of our new dedicated CPU plans. I'm going to set this to auto scale by ticking this box here. We're going to have a minimum number of containers as 1, and we're going to set a maximum number of containers as 10. I'm going to set my CPU threshold to something quite low so that we can trigger the auto scaling. So just before I save that, I want to explain what this means. So it means that as long as the CPU threshold averaged across your minimum number of containers is less than 30%, we will leave it at 1 instance. As soon as the average CPU threshold goes above 30% for your minimum number of containers, we will automatically scale. And we can see that happening live in this demo. So let me save that and let me just click through and create that resource. That's going to now go ahead and build our Node.js application. So our build has finished. Let's browse to our application. It's just a simple Node.js application that gives us some text each time. So we'll come to our Insights tab, and we see that after a while, our insights start to populate. So under CPU, we can see that the Node.js app is just idling there at 1%. What I'm going to do is I'm going to use Hey, which is a HTTP load generator. It's got a really simple CLI, and we're just going to generate a ton of requests to that instance. So let's copy our URL and let's send 200,000 requests to this endpoint. And what we'll see is in a minute, the CPU will start to spike, and then we will see under our activity tab, an auto scale event will trigger, and the app platform will start to add additional containers to handle this load. So you can see here now that Hey has finished sending our requests. It sent 200,000 requests and it got 200,000 responses, and they were all 200 status OKs. So let's come into our activity tab, and we can see a number of auto scale events, auto scale threshold met during those 200,000 requests. We'll come to our insights tab, and we can see that the app platform scaled us up to 5 instances at one point. And during that time, we were able to process all of those requests. So again, enabling auto scaling on the app platform is as simple as coming into your existing application, checking on set containers to auto scale, setting your thresholds and clicking save. And of course, if we were serving more static content, we could just change our cache control headers, and we could aggressively cache at the CDN layer as well. Another feature that we recently added is the ability to assign static egress IP addresses. And you may want to do this because your application needs to make an outbound connection to another cloud or an on-premise service, and you want to be able to whitelist that app platform application in doing that connection. So in order to add static egress IPs, all we do is we come to our application, and we've got this here, dedicated egress IP addresses. So we click on edit, and we click on add dedicated egress IP addresses. In a minute, we'll be given 2 IPv4 addresses, and any connections that are initiated from our app platform application will come from these dedicated egress IPs. So you can see we've got 2 dedicated egress IPs here.
Hello everyone, I assume I'm live. And I want to welcome you to my session. I'm Adrian Stanek. I am here today to talk about why we prefer the DigitalOcean App Platform. And this is a very personal point of me, because that was a long journey I was on with my company. So I want to quickly introduce a little bit who actually am I. And I am basically based in the small to medium-sized environment for 25 years now, with basically domain of media and IT. And I'm entrepreneur for 15 years. And during that time, being an entrepreneur in the tech industry, it's very often about how do you actually build software, how do you deploy software, and infrastructure is a very, very big topic. And I think one of the, let's say, I would even say one of the most concerning topics, because when you actually see what's going on, when it comes to infrastructure and small businesses, you see a lot of waste out there. And this is what I want to talk about today. So 15 years of being entrepreneur in that area. I'm fellow and mentor as well, which means I help other people understanding those topics better. I create content, I'm authoring articles, doing videos about that. And we as a company, we help as well other companies, other CTOs to make the right decisions in that way, so that we don't actually, or not everyone needs to go the hard way like we did. So our journey was from the typical data center journey back then, 2 decades ago, to the AWS cloud native journey we had. And we were pretty unhappy there, and I'll come to that basically later in that presentation. But it is very important to understand that we settled onto something we call Pearce, so Platform as a Service today. And this is actually extremely important for us today, because it made a lot, basically a big difference. And this is what I want to talk about today. There are 5 reasons I assembled. I saw that in the chat already. So what are actually the reasons? And Diane was already mentioning 2 of those, but I have actually 5 reasons we gathered with the clients, with the employees we have, basically what actually made us going to a platform and staying with our platform. And the first one is, so basically not in particular order, just throughout, but yeah, it's ease of use. So as you see or saw in Jack's presentation, it is extremely simple to deploy things. And it is like that in reality as well. So that means that when we take a look at how we actually do, let's say, start with the application, you can just do that by using the UI. And later on, if you want to scale, you go into it, you can go with APIs in Terraform. So you basically can do what you can do with everything else there as well. And so there is no limit. And what you avoid by that is actually going into very complicated setups. And this is what we saw at AWS a lot, of course, in data centers as well, no doubt. So if you do it totally yourself, it is not a good idea. I would not recommend it, and I'll come to that later, because you have actually other things to do than setting up your infrastructure, to be honest. That's not your main priority as a software development company. And yeah, that's actually what we want to avoid. We want to avoid complicated setups so it's easy to use. And the ease of use is probably the number one thing I can think of. The second thing is transparency and predictability. For most, probably the first point, but I saw that in comments early on, right? So you have transparency and predictability, which is oftentimes something people complain about when they use AWS. And they understand that AWS is made for different purposes than actually the small to medium-sized companies. And you don't have predictive costs. So you get a bill and you don't know what you find in that bill. You can't predict it. You don't know how much cloud spend, OpEx you will have in the first year or in 3 years. So it's covered in the beginning mostly with credits. And after the credits, it doesn't feel that good anymore. And this is a big difference when we went to App Platform. We basically know exactly what happens at the end of the month. And that's a big thing for a small company with a lot of constraints, working with a lot of apps, and we exactly need to know what every basically application will cost us regarding the static cloud spend. Okay, then the third aspect is the actual PaaS aspect, so platform as a service. So platform as a service is about infrastructure management hassles and removing them, avoiding them. So the platform as a service is, for me, the productized version of platform engineering. Platform engineering is a costly thing for mid-sized plus companies. You can do that in small companies as well, but to be honest, it is not the best idea I can recommend in that moment, because still you need to focus on development. I come to that later. And infrastructure is something which should work out of the box for you at best in best practice setups with the most common things when it comes to containers or serverless. While I personally prefer containers, the App Platform is a great space for that, but it can do both. There are serverless functions as well available there if you really like to do that. And the biggest benefit from the PaaS solution, as you can read here, is about focus on building applications. And that is so important. You need to focus on what you actually have in front of you. This is creating a software which solves problems for clients, for users, for people like that. And you need to focus on that and not how you actually run it, right? That is something which is solved by platform as a service solutions. The fourth point is significant cost savings. I promised some numbers before the session, and those are, let's say, I have some more of that, but those are numbers on average for an application. I will show in 2 or 3 slides how it looks like, but this is broken down for the first application. When we see that, when we basically run that in a professional sense for a B2B e-procurement client environment for about a mid-sized company as a client, this is actually what we saved from going from AWS to DigitalOcean. And I'm talking here about operational expenses, OpEx, if you like. It is not solely cloud spend. And this is so important about this session. Please understand that if you run a business, and that's now very important, I know developers sometimes have problems understanding that, but it is about the total spendings you have. People cost money, operations persons cost money, freelancers, contractors cost money, opportunity costs of CTOs doing AWS in their free time because they don't have other people is money as well. Basically, it's a fallacy. You are in there in that moment. And this is what we need to take into consideration. And this is how we came to basically saving 60% for the first app in the first month. And over 3 years, this is the time how long we now use the App Platform roughly. We basically have a total spending. So we are early adopters. We have a total spending of nearly 152% in total cost savings. This includes everything from setup, everything for this app on a larger scale business-to-business application. So the fifth point is the enhanced development focus. There is a number in there as well again. So we basically have a budget. We always have budget. We should have budgets. And when you basically have a budget which is limited, you don't want to spend it on things you don't need for reaching your goal. You want to always spend in towards your goal. And your goal is to create value. It's to create the outcome, the solution. And what you can save, you can then put again into basically this goal. And this is what we basically done. And this is the number. So we basically saved 2,680 per month per app, basically, by reducing, or for the first step, it basically it changes or smooths out a little bit, of course, with more apps if you scale a little bit. But this is actually the OPEX again. This is total cost of ownership again, where we were able to save money with. We don't need ops contractors anymore. There were no freelancers. There were no external people. There were no, let's say, opportunity costs missing by, or lost by CTOs or expensive seniors doing some stuff in AWS and that kind of thing. That is actually basically how we came to that numbers. And that's actually a big thing for us, because that then we can spend again per app into development again. And this is basically avoiding resource constraints. So what type of application actually I'm talking about right now? So this is when we take a look at our own applications, and the applications we run together with other clients and companies to help them to become a cloud native company. This is what we used to do a lot. This is the very basic application we see today, because many tech stacks use exactly that, or will be expressed in an application like that when they have the first services. So we talking about a little bit of mid-tier service, a little bit of pro-tier service, which is actually some lower shared things, some dedicated CPUs. It's not about LLMs or AI right now. It's really the traditional way of hosting applications in that moment. So we have 5 replicas, 30 replicas. This is round about what's there as an instance. We have a Postgres database with a read-only cluster. This is what I always prefer to do. Always have your read-only clusters. The red is the same, and an object storage S3 compatible. So this is the very basic setup. And this is where people tend to say, okay, let's go to cloud providers and start to compare the cloud spend, right? So you go to, or try to go to AWS and find out what that costs. And then you think, oh, it's actually not that expensive, right? But then you go to the next page, and then you start to put that into a list as well. And this is where the fun begins. This is where, where it becomes a little bit random and intransparent. So you need to have at least all those things, probably more than that, to actually run an application in any form successful, right? So we have, for example, the DNS. Well, you need a DNS, you need a load balancing thing, you need a NAT gateway. Those 3 things are perfectly done by the DigitalOcean App Platform already when you just take a look at it. The container registry is something you actually don't need when you use the app platform. You can use it, but you don't need it. That's a neat thing. Metrics as well. Metrics and alerts. If you have done that already yourself with Grafana, Prometheus, something like that, or Elk, then you know what I'm talking about. That is complicated. That is complicated to do, actually. Even if you have a service where you have sidecar containers in your Kubernetes, and you try to let them run, first of all, it's very expensive. The second thing, it's very complicated to manage, and it's basically hard to keep it up in the best practice way when you don't have specialists for that on board, which is oftentimes the case, especially in small to medium-sized businesses. And that is covered by the app platform in a way that you can actually use it quite well. So we have still Datadog as a log forwarder, but that's actually the only addition we use with our apps, and we can basically use with the alerting system and the metric system everything we need, as well as the CI/CD pipeline. CI/CD pipeline, a big example as well. In the past, we used a lot of TeamCity, if someone knows that, and Jenkins and GitHub Actions, because we love to use very complex ways of deploying things. That is all past. basically, we have build packs here. We have best practice setup here in the DigitalOcean App Platform. You basically build, test, deploy. That's it. And I really like that approach. It is very simple, easy to use. And as I said in the beginning, it's all about development, right? It's all about making the developers able to use those things. And everything I showed right now is usable and understandable by the average developer in our company, not by the ops persons, by the developers. And this is the nice aspect here. We're talking about that the average person who's working in our teams can use all those things. That was the horror in the past, to have it all siloed to some specific ops persons you might have as externals, a very good senior who's blocked by that, or even the CTO sitting there doing that themselves. And this is what I dislike, and it is basically gone with using the app platform. Okay, so let's go to some other numbers. How to save total cost of ownership per month for an app around these numbers I show you right now. So 2.6K a month, which is 60% compared to AWS, and nearly the same as we had with our own data centers. We still have those data centers as a legacy thing, so we have that numbers quite accurate. So what is that number? So when you take a look at the pricing pages, you won't come to that numbers, because this is not how you run a business. This is how you try to run a business in the beginning, and then you will get shocked by those bills and that things are not really working out. The real numbers are, it's a little bit more complicated. You need to, count everything into the opportunity cost, the total spending, the OPEX, the people cost money, the contractors, the initial setups of things. AWS setups cost several days of setting up probably, while DigitalOcean App Platform is a matter of 15 minutes. And those kind of things accumulate up to that number. So this is the number of basically the amount of money per month we actually save with the first application we set up in the newly environment with DigitalOcean. And this is up to 60%. And this basically was a thing we could reproduce several times, sometimes a little bit lower, sometimes higher, but this is the average number. Cloud spend, and this is what you see here, in several setups, when you start to calculate, they are pretty even. So it's roughly for us, when we took that, I updated the numbers before the session as well, it's around 16% in difference. So when you really go to AWS and start to tweak, you get to the same numbers. But as I said, it is mostly about the OPEX and where you really spend the money. Because the cloud spend is when you do it right, when you have modern tech stacks, when you really take a look at optimizing things, it is not the biggest issue you have. It is more like the people, especially we're talking about the context of small to medium-sized businesses. The most expensive thing is actually time and money of your people working on the product. And this is where you need to spend most, in my opinion, spend most emphasis on. And the cloud spend alone in average is lower, but the next slide could be very interesting as well, which is our averages. So even though I have said, okay, I will put on the left-hand side at least 1,000 there, because it was actually a little bit lower, because it is a little bit, we know what we do right now and stuff like that. But the idea behind that is that the OPEX, so the cost you actually have to operate that stuff, is way higher in AWS. For example, it is like AWS doesn't really offer you a platform as a service solution. It is not. So platform as a service is something which is brought to you off the shelf. You can use it and use it in a best practice way to run containers, network, and all those kind of things. When you take a look at AWS ECS, which we used before, the Elastic Container Service, you have so many things around that in order to make that happen, make that run. You need to have at least a specialized person who really knows how to operate that, because I'm not talking about my very first blog project. I'm a static website or something like that. I'm talking about where we need to deal with BISOs, CSOs, and stuff like that, who really take care that we're doing the things we do right. So data privacy, security concerns. We have basically high standards. We have clients in the enterprise level, so they expect from us to do it in the right way. So we need to make it sure that it actually happens. So we have SLAs which force us to have a very good uptime of those things and availability of persons who can work on those things. And this reflects in a number per app, actually, you run there. So you need to have at least a person every time there available to fix the environment, to make changes. And that is expensive. So you can help yourself and say, I don't need that, and then the numbers look better. But this is not how the reality works in that moment. And on the app platform, most of our apps are actually running way below that because we just let them run and they run, it's all fine. But if we accumulate that up and take a look at optimizations and stuff like that, we put some money there as well. So I put that into and have that number there as well. So I think that's a fair comparison. So we talked about that with other clients we're working with, other companies, and took on our numbers. And those numbers are very averaged. So they are average, but this is how we perceive it. And I think when you take a look deeper into it and think about yourself, you will come to something similar. Some told me it is lower on the right-hand side. Some told me it is way higher on the other side. So, but it was never vice versa. That is what I can say about that. And let's come to the last slide, which is what we have saved in 3 years while scaling 2 times. By scaling 2 times, I mean that we took the application, scaled every application by 2. So basically the first cloud spend we had scaled by 2. Was around 10 applications we're talking about there in the business-to-business area, e-procurement for larger companies. And per app, we could say that we had this saving over 3 years. And that is actually the saving which we had done because we moved away from data centers and then from AWS. These numbers are specifically about AWS. And that's actually a significant thing. And we're talking here really about total cost of ownership, not about cloud spend by itself. So all the costs you have around everything, all those bills you will not know, some 800 euro bills from Elastic Container Registry, you don't know why you got that, and something, your container was spinning up and you wouldn't seen that. Those kind of things we're talking about in average upscale to that numbers. And this is what I can say about that. Last sheet, then you have basically the chance to ask questions about that on the Q&A session. So why have we actually chosen our platform for us? The top 3 reasons is platform as a service reduces OPEX up to 60%. This is my absolute favorite because I'm an entrepreneur. I need to make sure that OPEX is in a state where we can actually use it. Damn.
Hey, Adrian. Okay, so let's jump into the Q&A.